Alright, welcome to your programming lecture. This time we're going to talk about loops in depth. We talked about them a little bit last time. And then our main example and also your programming assignment will be based around this idea of gaming called a platformer, which involves like moving right to left and jumping and doing cool things. That's like, I don't know, Super Mario Brothers. That's the idea if you've heard of that. Super Smash Brothers. So here are my goals. And let's get into loops. And we talked about one last time. It was called the repeat block. So it had repeat, and then you gave it like the number n, and it would repeat the contents, the things inside, and we call that the body of the loop. It repeats the body n times. It's R for run, n times. Okay, and so a loop is just a way of coming back to yourself and redoing things. Okay, so a loop is a type of block, keeps getting run, and you can say how many times, and you can also make it run forever. There's such a thing as a forever block that runs its body until the end of time. So that just keeps getting run. Which is fun to think about, and that'll be useful in a little bit. And yeah, so it's the inside, it's the body of that loop block that keeps getting run repeatedly, and you can put anything in there. You can put loops inside of loops if you wanted to, no problem. And then repeat until is the last block that is here. It's called no, I'm gonna show you that in a second. Don't worry, I was exploring. And repeat until, this one, repeats until a certain Boolean condition becomes true. So it's like repeat until your x coordinate is positive. Do something until then. Okay? That's the idea. And yeah, so just for completion's sake, I'll say repeat until, and then you put a little Boolean condition. And so this is like, let's call it cond. Repeat while cond, or repeat until, sorry. Until cond becomes true. And so it's false for quite a while, and while it's false, we'll just keep executing the body until it becomes true. Okay? So that's a lot of words. Let us have some action. So here's my Scratch Cat. He will be moving around a little bit in this first example. Let's have him start when the flag's clicked. And now we're going to have our friend the forever block. So it just so happens that every sprite has a direction at the moment. Right now his is 90, he's headed to the right, but we can change that. And well, let's watch that. Move moves you in your current direction, so click, click, click moves you. So let's have him do that. And if he happens to be on the edge, so he's up here in the corner, hopefully you can see my mouse, he'll just bounce off. And if I start him at a good angle, he'll be like that DVD screen in The Office. So forever, keep moving 10 steps, and if you're on the edge, bounce off of it. Whee! So the forever block is continuing to run the body, which involves moving, and then checking if you're on the edge, if so bouncing. That if on edge bounce block is doing quite a few things for such a tiny block, but I hope you understand what's happening. And the forever block is doing the heavy lifting. It's making sure this happens every split second, and so moving 10 steps is something that should be happening instantaneously, but really Scratch is making it easier for us, and it takes a certain amount of time to do that. So 10 steps is, I don't know, a couple frames maybe of this video that we are animating for ourselves. But I hope you understand what's going on here. The forever block is making sure that this keeps getting repeated, okay? And fun things happen because of it, okay? So I'll save that for you. And let us start afresh. Now let's do something a little bit more programmy. When we get into Python, this is the kind of stuff that you'll be doing. So we want to sum the numbers from 1 to 10. Okay? We want to do this programmatically, and so let's think of how we might do it. So let's think of our game plan. So let's make a variable that holds the sum. And if you think this is really easy, replace that with 100, for example. And we know that there's a formula for this, but let's pretend we didn't know it. Or we could make it extra fancy. We could multiply them all or something. But let's make a variable that holds the sum as we're working on it. So our programs are going to get pretty big in this lecture, and they're going to stay that big for the rest of this class. So just a warning. So we're going to have this variable called sum, and we're going to build up the answer, that is the sum of all the numbers from 1 to 10. Okay? In order to build it up, we have to start somewhere, right? And we have to keep on. First we'll add 1 to sum, then we'll add 2 to sum, then we'll add 3 to sum, etc. And so sum needs to be started off at 0, I hope you see. So start sum off at 0, then add 1 into sum, then add 2 into sum, ... Yeah? Then add 10 into sum, and then maybe we can print sum. So this adding, it's repetitive. Yeah? So let's put that in a loop. But if we could do this, I hope you see that it would work. First, we'd add 1 into sum, then it would become 1. Then we'd add 2 into sum, now it would become 3. Sorry, 1 plus 3. Then we'd add 3, it'd become 6, etc., etc. And then finally, we'd have the answer after we're done with the 10th number. We add 10 into it. So now, my job is to show you how we might program this in Scratch. So, not very graphical at the moment, but that's okay. We just had a graphical example. So let's make a variable, and we get one as we start out. It's called my variable, and that has a wonderful name, and we'll change it to sum. So when our program starts, let's just use the green flag again. When our program starts, we will start our sum variable out at 0, and actually, if you don't do anything to it and you just make it from scratch, it does become 0 at the beginning, but we want to always restart our program. So we'll set sum to 0, and then we're going to repeatedly add a number into sum, okay? And let's think about how we might do that. So we're going to repeat something, so we're going to need a block. Repeat 10 times? That might actually work for this one. That should work. We'll change that to repeat until. Hopefully I will remind myself. I can't ask you to remind me. So repeat something 10 times, and then sum will hold the right value. And once it's done, we'll just say it back. We'll say sum for 2 seconds. But what are we going to repeat 10 times? We can do stuff to our variables. We can change it. That'll work. We can change it by 1. But now, what's this going to do? I encourage you to pause the program right here and figure out what's going to happen. This is perfect as an example of what I might ask you on a test. So what will this print out at the very end? What will sum be? What will it say to us in its little bubble? So if we think about it, it's going to start sum at 0, then 10 times it will change sum by 1. Changing means adding, incrementing by 1. So the first time the body gets executed, sum will become 1. The second time, sum will become 2. The third time, sum will become 3. If I keep clicking this and then looking at sum, you'll see what happens. Change it once, now it's 4. Change it twice, now it's 5 from what it was. And so if it did this 10 times, starting at 0, what will sum be? I hope that you got the answer of 10. Now this is almost right. If we always changed it by 1, that would totally work, but we need to change it by another value. And now that brings us to our next variable. Let us make a second variable called, I don't know, to add. And that'll be the number that we add into sum. Yeah? And we'll start this variable out at 1. And then we'll add it to sum. And then we'll change it to 2. Then we'll add it to sum. Then we'll change it to 3. Then we'll add that into sum. And that's the way we can get the numbers from 1 to 10 into sum. Sum we need to not change. We'll change to add, and then we'll add into sum. So that is hard to explain with words, so let me just show you how this will work. I'm going to make a variable called to add, and that was what I called it, right? Yeah, to add. And it's going to start out at 0, so, sorry, it'll start out as 1, because that'll be the first thing that we add into sum. So we will set, no longer change sum. We will set sum to be whatever it was plus to add. I hope you see that. Sum, oops, to plus of sum and to add. Okay, so this is getting interesting, and I'll draw a diagram in just a second. And then I'm going to increment to add, change it by 1. And then after this, I will have the value that I was looking for. 55, is that true? That's, let's see, 10 plus 1, that's 11 times 10 divided by 2, so 11 times 5, yeah, 55 is the correct answer. But why is this working? Why did this do the right thing? And this is programming in a nutshell. Why does this work? I think I want a blank slide. And so these are the kind of programs that you will be able to write after a few lectures, or after this one. So at the start of this program, these two blocks happen, and they don't get repeated. Only starting here does things get repeated. So at the very beginning, sum is set to 0. To add, oops, is set to 1. Now we're here. Yeah? We're ready to start the repeat block. So we'll start it. We will execute the body the first time. We're going to do this, whatever we're doing, 10 times. So we will set sum to be sum plus to add. So sum will change from 0 to 1. And we're going to change to add by 1. So to add becomes 2. Okay? Normally I'd put this in the box, but I'm going to change this so much that I'm just going to start putting them outside. So then we come back to the repeat block to run it again. It's second time. So we'll set sum now to be sum, whatever it was, 2 plus to add. So sum becomes whatever it was, 1 plus 2 now. So it becomes 3. You see that? We're always adding the next number, and the next number is in to add. Then we'll change to add to 3. and then we'll come back for the third iteration of this repeat loop, we say. And then we'll set sum to be whatever it was, plus 2add. So it becomes 6. Then 2add gets incremented for the next time. Okay? And then finally, dot, dot, dot. At the very, very end, before it gets to 55, that'll be the last value, and 11, it'll be on 10. 2add is 10, and sum is 45. And that'll be the last time, the 10th time this gets repeated. So then it'll set sum to be whatever it was, plus 2add, which is 10 at the moment. Oops. And then it'll be set to 55, and then it'll change 2add by 1, which sets it to 11, but we'll never use that 11. And then we'll talk about our sum, print it out. So I hope that that makes this a little bit more clear, but again, this is something that gets concretized in your mind just through more examples, I think. Okay? And so every time the body of this loop gets executed, we call it an iteration. That's a word that I will be saying a little bit. It's called an iteration. And so that is our first real fancy example with loops. And I'd like to change this now to not use repeat, but to say repeat until. Okay? So we will repeat until. When did we want to stop? Well, we don't know what sum is going to be. We can't change that. We can't use that. But we know that we don't ever want to add that 11 into sum, right? We wanted to stop before we ever tried to do that. So this can be our stopping condition. Repeat until 2add is equal to 11. That'll be our stopping condition. How about that? Repeat until 2add is equal to 11. And now, let's do some surgery. Boop. Boop. This should be no different. 55. Very nice. And this is a hard-coded number. No, we don't like that. Let's ask. Let's ask the user. Where is that? Let us ask the user. I'll sum from 1 to n for you. Enter n. And so our n that we'll sum into is going to be saved into this answer variable now. If we wanted to sum from 1 to 10, well, we'll tell Scratchcat, yeah, enter 10, and then instead of putting 11 here, we'll put answer plus 1. It's always one more. Answer plus 1. And now this should be no different if we type 10. But now we can type more. Stop the program. How about sum the numbers from 1 to 100 for me, Scratchcat? 50-50. Nice. From 1 to 50? 1 to 3? So now we've made this very generic, and I hope that you've seen the logical process to get to here. We found our stopping condition. It was when our 2add variable was one more than we cared about, and then we didn't want to execute the body of the loop ever again. That's when we knew we had the correct sum. So that's the idea. stop when 2add is greater than n. Okay, hopefully that makes sense. Please walk through this on your own. I really encourage that. This is the way that you learn to program, by practicing and doing. So play around with this. I really encourage that. But now let's get into some more examples. So let us talk about the if statement some more. So we did a little bit, but let's have some more fun with it. Let's have a program called Do You Believe in Ghosts? And here, like everywhere else, if statements and our loops, they took a Boolean condition, and so these Boolean operations are useful, like and, or, and not. Those are available to you, and I will hopefully show you that. Okay. So, let me set the scene for you. I don't remember if I saved this, so I'm going to save it again. And I'm going to make a new project. And this is supposed to be spooky, so the woods, of course, is where this will take place. And let's find some ghosts to appear if the user believes in them. We'll have a skeleton. We will have a ghost which doesn't look like a ghost, and we will have, what else? Oh, a bat. That's pretty scary. Okay, here are our actors, and well, let's give our scratch cat a name. Now, what I want to do, here's my idea. I'm going to ask the user if they believe in ghosts. And if they do, actually, let's ask them twice. Are you really sure if you believe in ghosts? And if they do, we'll make a variable. We're going to make this variable called should show ghosts. And we're going to have that control whether or not the ghosts are on the screen. All right, so if this variable called should show ghosts is set to 1, I'll use 1 to represent true and 0, or any other number, to represent false. If it's set to 1, the ghost will be summoned. They will be watching that variable somehow. And they'll use that to show themselves. So, that's the idea. And now I can talk about showing and hiding as well. So, I think it's in, is it looks? Yeah. So, each of these, remember, when you click on a sprite, it gets its own little program. Show and hide are useful in this case. Hide just hides that sprite, and show shows it again. So we can make these tied to our should show ghosts variable, and let's make that now. So variables, we're gonna rename this existing one to should show ghosts, and just to give us practice, you can put spaces in these names, I think. But just to give us practice with Python, which we will be coming to, you cannot have spaces in a variable name, so I'm going to use underscores instead. All right, so the idea is ScratchCat, well, he's gonna start the play, and well, he will ask. That was in sensing, wasn't it? He'll ask, "Do you believe in ghosts?" And wait. And then, if the user said yes, we'll ask them again, because we want to make sure that they really believe in ghosts. So if answer happened to be yes, then we'll do something. And this is a special case, and where I don't think you have to use if-else. You can just use if. And in the case that this Boolean condition was false, nothing will happen. It'll just skip the entire if statement. So that's what an if statement by itself means. Or I guess in Scratch we call it an if block. So this might bite me in a second, but I think if we start the program by saying should show ghosts equals 0, that will solve it. So, so at the very beginning of the program, we're going to hide all the ghosts because we don't know what the user thinks yet. So add a comment. And then we'll ask, hey, do you believe in ghosts? And if they do, then we'll ask them a second time. So if answer happens to be equal to yes, because that's what we'll type. If it's yes, then we'll ask again. No, don't duplicate the whole thing. Go, there we go. Ask, are you sure? And then we'll have another if statement. So if they're extra sure, then we can finally show the ghosts. Are you sure? And wait. So one if statement, are you sure? And inside of that, a second if statement. So only if both of these get passed, only if both of these Boolean conditions are true, do we ever get to this, the meat, this inner if statement. All right. And if that's true, our game plan is we'll set that should show ghosts variable to 1. Otherwise, we'll set it to 0. And so in this case, we need an if else. Dun dun dun. Or actually, I think we still can get away with just an if statement because of the set at the very beginning. Sorry about that. I am programming on the fly. You gotta debug as you go. So if it's still yes, then we'll set our should show ghosts variable to 1, which will cause it to have changed from its initial value. And this will summon our ghosts. Okay? So the ghosts are supposed to be watching this variable, this should show ghosts variable, and they'll know then to hide or show themselves. Okay? So the way that they can do that is to watch the variable using a forever loop. That's the way that I came up with in my mind. Please let me know if you think of a better way. So again, this entire program is going to start for every single sprite when the green flag is clicked. And I know our programs are getting big now. It's hard to keep them all in our heads, so I really encourage you to keep looking at this code when I post it. Okay, so, or follow along with me and stop whenever you want to make sure that you know what's going on. So when this is clicked, we will have a forever loop that keeps on checking, hey, should I be showing myself? So if should show ghosts is equal to 1, or is equal to 1, then I will show myself as a ghost, because that is what summoned me, this 1 value. It's true. Otherwise, that means it was 0 or some other value, and I'll use that to mean that I should hide myself. So every time this program runs, every split second, forever, it will keep checking this if statement. Should I show myself? Should I hide myself? And the second that should show ghosts gets set to 1, they'll show themselves. But at the very beginning of the program, we set it to 0, and so they will immediately, when the program starts, hide themselves. Okay? So I'm going to give this program to everybody. Boop. And boop. So every ghost, or ghost-like creature, has this same forever loop that tests whether or not they should show themselves. So alright, so let's see if it's working now. So the idea is we're going to start the program, set should show ghosts to 0, which will cause them all to disappear because they're watching this variable, and right now I just set it to 0. So they're always repeating this if statement and always hitting the else block. They're just constantly hiding themselves. And now we're sitting right here in the Scratch Cats program. We're asking, do you believe in ghosts? And well, let's say no. If I say no, I'm going to skip this entire large outer if block because the answer was not yes. Program's over. At least for the Scratch Cat. Everybody else has that forever loop going forever. Okay. What else can happen? So if I say yes the first time, then I'm sitting waiting here. It'll ask, are you sure? And I can say no, or something else other than yes. And again, it'll skip this if statement. And the Scratch Cat is over. It's done. But if I say yes twice, I will hit this final inner if body. And that will set that variable, should show ghosts, to 1, wait for it, and all of these beautiful sprites that have been waiting, they've been waiting for their close-up, and now their time has come because should show ghosts now equals 1, and they will all keep going forever. Show, because this value can never change now. We set it once and we're done. Okay? And so it's kind of inefficient because they're stuck in this loop and they don't really need to be in a loop anymore, but who cares? We did the right thing. So that's fun, I think. I hope this is fun. And I really encourage you to play around with that. So that is a very in-depth example of what's happening. And so, yeah, I think this is a bit pretty much what I was saying. So when I enter the answer, I will change the value of the answer variable, and that's just what happens when you use the ask block. And I'll use that value to change the value of the show ghosts variable using an if statement. And really I should say block. Everything is a block in Scratch, but I'm used to programming in non-block languages, so I say statement a lot, but I hope you know what I mean. So yeah, each ghost just continuously checks that variable and either hides or shows themselves, depending on whether or not that thing is 1 or a non-1 value. And again, I can't remember if I saved this, so I'm going to save it now. Alright, how we doing on time? Not too bad, not too bad. So, what I want to get into now is this idea of a platformer game, and that will be your next programming assignment. So, what will happen is I will make a new project. Here I am. And my computer just like turned on its fan super loud, so I'm going to reload this page just in case that was its problem. Okay, but now we're back. Fresh Scratch program. And so a platformer game, if you've never heard of it, it's like it's one that involves moving around horizontally, jumping and interacting, like the classic Super Mario Brothers. Like, you got your Mario, he can go left or right, he can also jump, and he can do cool stuff if he like hits the question block or something like that. That is your standard platformer game. You're jumping across, like, from platform to platform. That's I guess the idea. And we're gonna make one. So here I am in Scratch, and well, let's do this thing. I think I'll just have some ground, some normal ground for the Scratch Cat to walk on, and I won't ever let him go underneath the ground. So let's find something that looks like ground for this cat. Line is probably the standard answer, but let's see if there's anything better. Trampoline, perhaps? No, I think I'm either happy with the line or the paddle. I like the paddle. Let's see if we can make the paddle giant. Can we? Dun dun dun. Giant paddle. That's probably not the best idea, but hey, who cares? Okay, so he's on the paddle. He can move left and right, and the idea is we want to allow the scratch cat to move. So we will use key combinations and pretend that our keyboard is a controller. So if you press left, we will move the scratch cat to the left. And how might we do that? Well, look at what happens down here when I move the scratch cat to the left. Which value of interest changed? That would be the x value. These are the x coordinates changing. I'm trying to keep the y coordinates the same, but obviously I am having trouble with that. But that's the idea. If we just change the x coordinate in a certain way, the scratch cat will move in the correct direction. So we can say change x by some negative value, because negative values are that way. Smaller values are to the left. So when I press the left arrow, boop, 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 things are happening. And I think that's a bit slow, so let me speed them up. Move by 20, please. Yeah. And then I'll duplicate this, because when the right arrow is pressed, let's change the x by positive 20. And I'll move them back to the right. Whee! Whee! So now we have a moving cat. And the last piece of the puzzle is, I guess, jumping. So I want to make the scratch cat jump, and this is going to be interesting. So jumping, I think the way that I want to implement this, and you can choose your own way. You'll have a programming assignment, and I want you to be creative and not do exactly the same thing as me. You have to do something different. And so my idea for jumping is this. I'll set the scratch cat's y value to be a large thing. And you don't have to use the scratch cat in your programming assignment. I'll set its y value to be large, so I'll increase by a large amount. And that'll be the initial jump part, but he has to fall back down, you know? So, let's see. Space. So I'm gonna change your y, like, by 150 or something giant. And that'll be your jump, scratch cat. But that's all well and good, but here you are and you're not coming down. So I think when the space key is pressed, what I'll do to bring the cat back down is to use a loop. So maybe I will repeat until the scratch cat touches the paddle, and I will decrease your y in a negative way, because negative y means down. And so let me just click this to see if it's going to work. Ooh, I like that. You see that? So until touching paddle. So that's meaning while the scratch cat isn't touching the paddle, I'm going to keep executing this body, but the second the scratch cat touches that thing, I'm done. I hope you see that. So bring him down a little bit at a time, and that's for animation. This gives the illusion that he's moving, just repeatedly doing something. So once he touches the paddle, stop the loop. And that's the beauty of this. That's the beauty of loops. They can do arbitrary things. And so I press left, I press right, and I press space. The scratch cat jumps high and falls right back down. Isn't that beautiful? And I can actually, by virtue of pressing space and then pressing the right or left key while he's falling, I still get I can have him move a little bit as he's in the air. And that's just an artifact of our implementation. We didn't have to change a thing. Whee! So this is where this gets really fun, and I hope you're enjoying this. This is where programming gets really interesting. You have all the tools now to build a game. So, how we doing? Yeah, in like the last 10 minutes, let's do something fun. So, and then I will let you start working on your programming assignment. Let's see here. So, yeah, I will give him a little place to go, a little, let's say, a little block to touch. Like if this were Super Mario, he'd get a coin, right? But maybe he's looking for a ball's like a coin, a bell. Let's see, what do cats really like? They like fish, right? How about that? So you'll get a fish. Maybe it's a tiny fish. I don't know. 50. Yeah, that's a little too tiny. 75. Yeah, let's just keep it at 100. Why not? So here's the fish in the air, and maybe this is the prize. This is like the coin in our game. And well, if I touch the fish, I should obtain it. That's how these games work, right? So how about we give the fish a little loop to see if the scratch cat touched him. And, well, that means we'll need to start the program somehow. So maybe we can start the program with the flag. So when we click that flag, the fish, because I'm on the fish's program right now, the fish will keep checking if the scratch cat has touched him. So that's sensing again. So am I touching? That's the touching question. So if I'm touching, not sprite 1, no. You need a name. There, we have given you a name. If the fish, this is the fish's program again, if the fish is currently touching the scratch cat, and it'll keep checking this forever, well, then maybe like the scratch cat has gained a point, and I don't know, have a variable called points, and we will I don't know, we'll change points by 1, and then we'll I don't know, hide the fish. Where'd the hide go? Hide the fish, and maybe we'll move the fish to some random place. Like, I don't know, go to random position. But that might ruin things in a second, but we'll figure it out. Go to a random position, and then after a few seconds, show yourself again. Wait 1 second, and then show yourself. So this is a big one. So if this fish is touching the scratch cat, that means the scratch cat has obtained the fish. We're going to increment the points variable by 1. Then we'll hide the fish, move him somewhere random, wait a second, and plop him again onto the display. Let's see what happens. So I click the flag, the fish is running in its loop checking if the scratch cat's touching him. Well, I can move the scratch cat, boop, touch him, oh, and he moved. But the problem with the current program is the fish can go places that the cat cannot currently go. So this random position will not suit our purposes. I think what we can do maybe is change the random position to maybe a random Y position. We'll say something like, I don't know. It's still motion, right? Go change, yeah. Let's set Y to be a random value. Yeah, so we'll set the X. The X of the fish. So the X will only ever change, and not the Y. So the fish will just randomly pop and appear, like over here, then over there, then over here, then over there. That's the idea. So I'm going to set the x to a random value. And I just need to find the random block, which I don't remember where it is. So you're probably screaming at me through the screen, but that is okay. So let's see, what are my values of x's? Like negative 250 to positive 250? Sure, let's go with that. Negative 250 to positive 250, and we'll set the x to be a random value between those things. And so now the fish will only ever move horizontally, but it'll take a second for him to appear. So once I hit this fish, I will increment my points, I will hide the fish, I will wait 1 second, and then I will move the fish to a random spot and show him. Boop. 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 And then maybe I should also show the points. We can start the points out at 0, and we can show the variable points every time we increment it. Boop. Points is 1 now. Points is 2 now. Points is 3 now. Points is 4 now. Points is 5. So yeah, every time the Scratch Cat touches the fish keeps checking forever and ever. We're going to increment the points, hide the fish, wait a second, randomly move the fish to a place horizontally, show the fish, and then show the points. And this is where your creativity comes. This is as good as I can do. I want you to do better. You can do cool stuff with the backgrounds. You can be like, looks, switch backdrop to a different one when this happens. Things like that. So I really encourage you to go crazy here. Because of that, because this is essentially a, let's see, you're going to be implementing this, in essence. I don't know, I haven't decided if I will give you the code for this. I mean, but you can still see it in the video, of course, so maybe I should just give it to you. But that brings us to your programming assignment. And so, did I number these properly? Did I call the first one 0? Yeah, good. So this is your programming assignment 2, and so your job is to implement a Scratch program with these features. So I want your character sprite to walk and jump. You can pick whatever sprite you want. I want something cool to happen when you touch or jump into another sprite or sprites. Okay, so something like I did. So I want you to be creative, so don't copy me. And I want to make sure that there are at least 2 loops in your program. Okay, so hopefully that is reasonable. And yeah, use my lecture demo as a starting point, but you should be doing something unique. And for submission, I want you to upload a video. I want you to demonstrate your program to me, explain it to me, just very briefly. So I want to hear your voice for about, I don't know, 30 seconds to a minute, and that is the length of your video. So just walk me through it, be like, hey, cat, fish, jump. Oops, it wasn't running. Cat, fish, jump, points, etc. 30 seconds to a minute of that. Just prove to me, show me your program, all of it. And yeah, I just want to see how creative you are. So with that, go get started. I know that the programs this lecture got a bit larger, but that's just the nature of programming. We got to step it up a little bit, and that's the idea. So I hope that you still find this entertaining and fun, and yeah, please exercise your creativity on this next programming assignment, and I will see you next week. Oh, I just remembered something. I want to show you how we can use what we learned about in our previous lecture to do cool stuff. So here is an AND operation. So we can change this, just briefly. If the Scratch Cat is touching the fish and the points is less than, like, I don't know, 5, then we can do cool stuff. Otherwise, the points will never get above 5. And so this isn't idea where you can, this is an example of using Boolean combinators, our ands, our ors, our nots, to make complicated programs. And maybe you could make this an if-else statement and say, hey, you won the game in the else case. So this will only let the points ever get to 5. Now nothing works anymore because this and statement is guarded by touching and points less than 5, and points is now equal to 5. So I just wanted to say that very briefly. Enjoy that.